So let's take a look at this first example where that quadratic function is in that form that we recognize. So when I look at that, there's two main pieces that I'm looking for. First of all is my transformation. So in the fact that I know that inside here I have x minus 3, so that's going to move it right 3. And then I have a plus 8, so that's going to move it up 8. So basically think about the fact that if you started at the origin, so if we started here at 0, 0, we would go right 3 units, right 3, and then up 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we right 3 and up 8. So there would be my point there. And that point right there represents my vertex. It's at 3, 8, because again, I moved it right 3 and then I moved it up 8. So that would be my vertex. So that is just your old transformations that you know. Minus moves it right, plus moves it up. So I went right 3 and up 8, so I immediately have my vertex. And then the second thing that I'm looking for is I'm looking whether this value out here in front of the parentheses, is it positive, is it negative? So in this case, the value is negative. Again, we didn't talk about what the 2 does in terms of stretching and shrinking the graph. However, we did talk about the fact that that negative was a reflection, or in this case, it made my graph open down. So we now have a rough sketch. This is not going to be very accurate at all, but this is just a rough sketch of what that graph looks like. So we moved it right 3, up 8, and now we know that it opens down. So then immediately I know that there's this imaginary line that I'm drawing as a dotted line right here that runs right through that vertex, which represents that axis of symmetry. And so my axis of symmetry is going to be at x equals 3. Don't forget to put the x equals in front of it. And then now, this is why I would encourage you, even if they don't ask you to draw a sketch of it, I would encourage you to at least draw you a rough sketch of it, so immediately you know you can just look over there and say, okay, there's my imaginary line running right through that vertex, so my axis of symmetry is at x equals 3. The next thing I know is that that parabola is opening down. So if that parabola is opening down, that makes this value over here at 3, 8 a maximum. And so I know that it's a maximum. And my maximum is at that vertex there, which is, you can either write it as an ordered pair, or you can write it sometimes as my math lab wants you to write it, which is y equal to 8 at a specific x value. Doesn't matter which way you write it. The main thing is knowing that is it a maximum, is it a minimum value? And I answered the next question on that same line. Sorry about that. So that maximum or minimum value would be here at y equal to 8. When you refer to the value of the max or min, you're talking about the y value. So again, think of it as an ordered pair, but the actual maximum value is that y value. And then the next thing that we get is we get the range. So that's going back to things that we did back in chapters 1 and chapter 2 when we were looking at functions in general. But if I'm looking at that picture, then I notice that my graph never goes above that line right there at y equal to 8, which is where I have that maximum. And then I know that it opens down, so that it goes all the way down to negative infinity. So I immediately know that my range is from negative infinity up to and including that maximum there at 8. So whether or not they even ask you to draw a sketch of the picture, I would encourage you to do it, because then you're just looking at that picture and just going through and answering off those questions. But everything is in front of you if you're in that form where the square has been completed for you, where it looks like it did when we were doing our transformations back in 2.5. So let's take one more example, and then we'll look at the other form that we have. So here we have 5 times x plus 3 squared and then plus 10. So again, immediately I recognize the form that is in is my form for my transformations. So I immediately know that that's moving it left 3 because it's plus 3. So that's moving it left 3, and then that plus 10 is moving it up 10. So it's left 3 and up 10. So if I started at the origin and I counted left 3, so left 1, 2, 3, and then up 10, so 1, 2, 3, 4, 5, 6, 7, 8, going to go off my grid here, 9, 10, then I know that my vertex is there at negative 3 because I went left 3. So negative 3 went up 10, so positive 10. So there's my vertex there at -3, +10. And then the next thing I look for after I do that is I look out here at this value. Again, we didn't talk about necessarily what the 5 does, but the fact that it is a positive value tells me immediately, and so I'm going to go through my typing here, but immediately I know that that graph opens up. Again, this is just a sketch. This is not exact. This is not even as exact as I asked you to do on those other problems where I asked you to label 3 points. I'm just looking for a very rough sketch of what that graph looks like. And all that's going to do is help you answer all the questions that follow if you draw that sketch. Because now I know that there's this line running right through that vertex, that imaginary line right there running right through that vertex, which is at x equal to -3. So I immediately know that my axis of symmetry is at x equal to -3. And then by looking at that graph, I notice that that graph opens up. So I know that that point there where I have my vertex, this point here at -310 where I have that vertex, it's the smallest point on my graph. And so in that case, it's going to make it a minimum value since it's the smallest point on that graph. And that minimum value occurs at that y value, which happens to be at y equal to 10. Again, think of it as the ordered pair -3, 10, but when you're talking about the actual value of the max or the min, you're actually referring to the y value. So in that case, y equal to 10. And then again, I can answer that last question. I can answer that question of what is the range of my graph. Well, in this case, my graph never goes below that horizontal line right there, which is at y equal to 10, but it does go up from there. So it goes up to infinity. And so the range of my graph would be from 10 all the way to infinity. Now, some other questions that they might ask you. So let's talk about just a couple other questions that they might ask you. One other question that you might get asked is to talk about where is this function increasing and decreasing, which again, we've talked about previously, but it's just kind of putting everything together in terms of what we've talked about up to this point in the class. So if I'm looking at where this function is increasing or decreasing, I am now looking at using my x values. And so this value here for my vertex, the -3, the x value is going to be very important. So I'm looking at where that function is increasing, where that function is decreasing. So remember that this is a quadratic function, and so I know that my domain is all real numbers. So I'm going to go from -infinity all the way to +infinity. And so if I read that graph from left to right, then I'm going to do it in a different color here. This portion of my graph right here is going down if I read it left to right. That portion's going down, so that portion is decreasing, and that is if you're looking left to right, not up to down, but looking left to right in terms of your x values, that function is decreasing from -infinity to -3. Again, looking at my x values that correspond to that. So if I was down here looking at my values on the x-axis, those values are coming from the left of 0. So coming from this direction here, so that is going to -infinity to -3. And then when I get to this, to my vertex, then my graph turns and it goes up, or this portion is increasing, which if I'm looking at my x values here on the x-axis, those are values that are going to +infinity on the x-axis. And so my function is increasing from -3 to infinity. So you can still answer the questions of increasing and decreasing. For quadratic functions, you're going to have one piece that's always decreasing and one piece that always is increasing. Just depends on looking at your graph which piece that happens to be, and that depends on whether it opens up or down, which piece that's going to end up being in terms of increasing and decreasing. And then the other question that they may ask you that I'm not going to actually work an example out of, but what we did in class today, which was when we were solving those equations where we were taking the square root of both sides. So if you have a function in that form, you can actually find the zeros of that graph by using those techniques that we talked about and are going to talk about more of on Monday from section 3.2. So I won't bother to do those right now because we're going to do plenty more of those examples in class. But that's the other question that you may get asked, is to find the zeros of these various types of quadratic functions. Okay, so that's the two examples of the first form that you have, which is basically just your transformations, moving it left, moving it right, moving it up, moving it down, and then whether that value out front is positive or negative, and then being able to answer all those questions. So I'm going to show you the other form that you're going to see for quadratic functions. I'm going to show you how to find the vertex and then how to go through and answer all those questions that they're going to ask you there.